Okay, so here we have to solve this rational equation. We have x over x squared minus 8x minus 9 is equal to 5 over x squared minus 81. And at first glance, you might say, well, we can just cross multiply, right? Multiply both sides by both denominators. That'll cancel out both denominators, and we'll get, x times this whole thing is equal to 5 times this whole thing. But notice, a little bit of foresight, you can see we are going to get an x cubed term when we multiply these two. And so x cubed, cubic polynomials, kind of tedious to solve. So I'm going to choose a different method, which is factoring the denominators, right? Notice how this is a difference of squares, right? 81 is 9 squared. And this trinomial, you'll notice you can also factor that one. And so that's probably going to be a simpler solution. And so the difference of squares, right? That's x minus 9 times x plus 9. And on the left here, we have x minus 9 times x plus 1. And so if I want to clear both denominators, what I can do is multiply by each of these factors. But notice, so I'm going to multiply both sides of the equation by x minus 9, x plus 1, and I already did x minus 9 here, so I don't have to do it twice, and x plus 9. So I'm going to multiply by these three factors, x minus 9, x plus 1, and x plus 9. And when I do that, both sides of the equation, right? On the left side, the x minus 9s and the x plus 1s, they'll both cancel out, right, when I multiply by them. But the x plus 9 will not, right? There's nothing to cancel that out, and so I'll be left with x, the numerator, times x plus 9. Now on the right side, when I multiply by x minus 9 and x plus 9, those will cancel. But when I multiply by x plus 1, that's not going to cancel. And so I'll have 5 times x plus 1. Again, here, what I did was I looked what's kind of the lowest common multiple here, and then I multiplied by that, so I cleared both denominators. I canceled out both denominators by multiplying both sides of the equation by the same thing. And so now what I have, you can see I'm going to have a quadratic here. I'm going to distribute the x to both terms. So I have x squared, x times x is x squared, x times 9 is 9x. On the right, I have 5 times x, that's 5x. 5 times 1, that's 5. So now what I have is a quadratic equation, which I can solve either by factoring or using the quadratic formula or something like that. So I'm going to move all the terms to the same side of the equation, to the left side, right? So I'm going to subtract 5x from both sides and subtract 5 from both sides. And so on the left, I have 9x minus 5x, which is 4x. And that negative 5 moved over to the left, and you can see now it's equal to 0. And can we factor this? Well, we can. So it's going to be factored into x plus 5 times x minus 1 equal to 0. And so now we just set each individual term equal to 0, and we solve for x. So we get x equals negative 5 and x equals 1. Well, what's important to note is that we have to check these answers, right? We might be dividing by 0 in the original equation. And so when we do that, again, take a look. What are our roots of this equation? Well, actually, we factored it, so we actually know what the roots are, which is 9, negative 1, 9, and negative 9. And none of these numbers are either of those. And so these two are indeed our solutions to this equation, right? If, let's say instead we had x equals negative 1, and we found that as one of the solutions. But notice here, negative 1 would make this left side undefined. So this equation is not even valid for negative 1. And so we would have to discard that solution. But in this case, both of them work with the original equation. And so those are our final answers.